Group Activity 5, Data Pre-Processing. Next slide.
So, ano nga ba yan?
Sige.
Group.
What is data pre-processing? Data pre-processing is a step in data mining and data analysis process that takes raw data and transforms it into a format that can be understood and analyzed by computers and machine learning. Raw, real-world data in form of text, images, video, etc. is messy. Not only may it contain errors and inconsistencies, but is often incomplete and doesn't have a regular uniform design. Machine like to process nice and tidy information. They read data as ones and zeros, so calculating structured data like whole numbers and percentages is easy. However, unstructured data in the form of text and images must first be cleaned and formatted before analysis.
So, data pre-processing importance. When using data sets to train machine learning models, you'll often hear the phrase garbage in, garbage out. This means that if you use bad or dirty data to train your model, you'll end up with a bad, improperly trained model that won't actually be relevant to your analysis. Good pre-processed data is even more important than the most powerful algorithms, to the point that the machine learning models trained with bad data could actually be harmful to the analysis you're trying to do, giving you garbage results. Depending on your data gathering techniques and sources, you may end up with data that's out of range or includes an incorrect feature, like household income below zero or image from a set of zoo animals that is actually a tree. Your, your set could have missing values or fields or text data, for example. You'll often have misspelled words and irrelevant symbols, URLs, and other stuff. When you properly pre-process and clean your data, you'll set yourself up for much more accurate downstream processes. We often hear about the importance of data-driven decision making. But if these decisions are driven by bad data, they are simply bad decisions. So, understanding machine learning data features. Sige, kira.
Datasets can be explained with or communicated as the features that make them up. This can be size, location, age, time, color, etc. Features appear as columns in datasets and are also known as attributes, variables, fields, and characteristics. Skip natin yan. It's important to understand what features are when pre-processing your data because you'll need to choose which ones to focus on depending on what your business goals are. Later, we'll explain how you can improve the quality of your datasets, features, and the insights you gain with the processes like feature selections.
Um, Legit pa man din sa Wikipedia.
Uh,
Okay, okay yan. First, understanding machine learning data features. First, let's go over the two different types of features that are used to describe data: categorical and numerical. Categorical feature whose explanation or values are taken from a defined set of possible explanations or values. Categorical values can be colors of a house, types of animals, month of the year, true or false, positive, negative, neutral, etc. The set of possible categories that the features can fit into is predetermined. So numerical features with values that are continuous on a scale, statistical or integer related. Numerical values are represented by whole numbers, fractions, or percentages. Numerical features can be house prices, word counts in a document, time it takes to travel somewhere, and stuff. So, pre-processing steps. So, ito ang pre-processing step, data quality assessment, data cleaning, data transformation, and data reduction. See daw.
Sige. Data quality assessment. Take a good look at your data and get an idea of its overall quality, relevance to your project, and consistency. There are a number of data anomalies and inherent problems to look out for in almost any data set. dataset. For example, mismatch data types. When you collect data from many different sources, it may come to you in different formats. While the ultimate goal of this entire process is to reformat your data for machines, you still need to begin with similarly formatted data. For example, in part of your analysis involves family income from multiple countries. You'll have to convert each income amount into a single currency, mixed data values. Perhaps different sources use different descriptors for features, for example, man or female or male. These value descriptors should all be made uniform. Data outliers. Outliers can have a huge impact on data analysis results. For example, if you're averaging test scores for a class and one student didn't respond to any of the questions, their 0% could be greatly skewed in the results. Missing data. Take a look for the missing data fields, blank spaces in text, or unanswered survey questions. This could be due to human error or incomplete data. To take care of missing data, you'll have to perform data cleaning.
So data cleaning. Data cleaning is the process of adding missing data and correcting, repairing, or removing incorrect or irrelevant data from a dataset. The data cleaning is the most important step of pre-processing because it will ensure that your data is ready to go for your downstream needs. Data cleaning will correct all of the inconsistent data you uncovered in your data quality assessment. Depending on the kind of data you're working with, there are a number of possible cleaners you need to run your data through. Missing data. There are a number of ways to correct for missing data, but two most common are ignore the tuples. A tuple is an ordered list of sequence of numbers or entities. If multiple values are missing within tuples, you may simply discard the tuples with that missing information. It's only recommended for large data sets when a few ignored tuples won't harm further analysis. So manually filling in data, missing data. This can be tedious, but it's definitely necessary when working with smaller data sets. Noisy data. Data cleaning also includes fixing noisy data. This is that this is data that includes unnecessary data points, irrelevant data, and data that is more difficult to group together. Binning. Binning sorts of data. Sorts data of a wide data set into smaller groups of more similar data. It's often used when analyzing demographics, income. For example, it can be grouped as 35K to 50K, 50K to 75K. Regression. Regression is used to decide which variables will actually apply to your analysis. Regression analysis is used to smooth large amounts of data. This will help you get a handle on your data, so you're not overburdened with unnecessary data. Clustering. Clustering algorithms are used to properly group data so that it can be analyzed with like data. They are generally used in unsupervised learning when not a lot is known about the relationship within your data. If you're working with text data, for example, something should you should consider when cleaning your data are remove URLs, symbols, emojis, etc. that aren't relevant to your analysis. Translate all text into the language you'll be working in. Remove HTML tags. Remove boilerplate email text. Remove unnecessary blank text between words. Remove duplicate data. After data cleaning, you may realize you have insufficient data for the task at hand. At this point, you can also perform data wrangling or data enrichment to add new data sets and run them through quality assessment and cleaning again before adding them to your original data. So, yun. Data transformation.
Data transformation. With data cleaning, we've already begun to modify our data, but data transformation will begin the process of turning data into proper format you'll need for analysis in other downstream processes. This generally happens in one or more of the below: aggregation, normalization, feature selection, discretization, concept hierarchy generation. Next slide.
So, yeah.
Data transformation, aggregation. Data aggregation combines all of your data together in a uniform format. Normalization scales your data into regularized range so that you can compare it more accurately. For example, you're comparing employee loss or gain with a number of companies, some with just dozen employees and some with 200 plus. You'll have to scale them within a specified range like negative 1.0 or 1 to 1.0 or zero point 0 to 1.0. Feature selection is the process of deciding which variables, features, characteristics, categories, etc. are most important to your analysis. These features will be used to train ML models. It is important to remember that the more features you choose to use, the longer the training process and sometimes the less accurate your results, because some feature characteristics may overlap to be less present in the data. Discretization pulls the data into smaller intervals. It's somewhat similar to binding, but usually happens after data has been cleaned. For example, when calculating average daily exercise, rather than using the exact minutes and seconds, you could join together data fall into 0 to 15 minutes, 15 to 30, etc. Concept hierarchy generation. Hierarchy generation can add hierarchy within and between your features that wasn't present in the original data. If your analysis contains wolves or coyotes, for example, you could add the hierarchy for their genus, Canis. Next slide.
Sige na.
Hmm.
Data reduction. The more data you're working with, the harder it will be to analyze. Even after cleaning and transforming it, depending on your task at hand, you may actually have more data than you need, especially when working with text analysis. Much of regular speech, human speech, is superfluous or irrelevant to the needs of the researcher. Data reduction not only makes the analysis easier and more accurate, but cuts down on data storage. It also helps identify the most important features to process at hand. Attribute selection. Similar to discretization, attribute selection can fit your data into smaller pools. It essentially combines tags or features that tags like male, female, and professor could be combined into male professor or female professor. Numerosity reduction. This will help with data storage and transmission. You can use a regression model, for example, to use the only data and variables that are relevant to your analysis. Dimensionality reduction. This again reduces the amount of data used to help facilitate analysis and downstream processes. Algorithms like the k-nearest neighbors use pattern recognition to combine similar data and make it more manageable. So, data pre-processing examples. You can look at the table below to see how pre-processing works. In this example, we have three variables: name, age, and company. For example, we can tell that 2 and 3 have been assigned to the incorrect companies. Diba to? Elon Musk, Amazon. Oo nga, Amazon.
Balik yung
Siya nga.
pagkakalagay sa kanya.
Hindi ko kilala si Karen Lynch. Sino ba yung 2 and 3?
Correct lang.
Ay, hindi tama. Mali nga yung dalawa. Si Elon Musk, Jeff Bezos pala. 2 and 3 nga. Tama, mali nga. Tesla yung dalawa.
Mali. Sa kanya yung Tesla.
Oo, baliktad. Ito.
Yung next.
We can use
Data,
data cleaning to
oh,
simply remove these rows. As we know, the data was improperly entered or is otherwise corrupted. Or we can perform data transformation, in this case manually in order to fix the problem. Yun na nga, binago na nga. Pinalta na.
binagad.
Oo, ayan na. Once the issue is fixed, we can perform data reduction, in this case, by descending age. Choose in which age range you want to focus on. Yun na, pababa na ng pababa. Pinakamatanda taas,
Si
pinakabata
Tim.
pababa. Tim Cook to Elon Musk. Ayan na. Tapos na.
Tapos na.
Ito yung references. So, we're good. Ayos na baga. Kaintindi mo kayo, ano? Pwede na yan.
Ano, nakat mo na yung
Oo.